this is an ACF, and normally the autocorrelation function at lag 0 or the first lag is normally at 1. So it is not surprising to be seeing this lag being 1 over here, because the autocorrelation function for lag 0 or the first lag is normally what 1, because you did the proof and you saw how the variance or the covariance is going to be dividing itself. Anytime you have YO dividing YO, normally you're going to be getting what 1 over here. So now we can also do a partial autocorrelation function. Now with this, you can see that you have a geometric decay over here. The lags kind of fall step by step. It doesn't fall just once, it just falls step by step for you to do all that. And now you can see there is a geometric decay over here for you, and this tells you that this is an AR process, or this is an AR model. Now you can use the ACF function to do that. Is a partial autocorrelation function. Partial autocorrelation function, that is the PACF. And now you can run this and look at this over here. It's only the lag, it's only lag of 1 which is standing tall. So over here the highest is 0.5, because we don't even have any lag more than 0.5 when it comes to PACF. So the highest here is 0.5, and then the lag of 1 is just probably the one which is outside this range and all that. Now what is an MA process? We were saying that with MA process you are going to forecast something based on what past error themes and all that. So now let's look at that one too as well. We have this one, and you can equally do an ACF plot and then a PACF plot. With the ACF plot, when it comes to MA process, we're saying that there's a cutoff after the first second lag. After some few lags there's a cutoff. So you can see that after the lag of 0 is normally 1, so that one is not surprising. After the second lag, or the lag after lag 1, you can see that the thing falls down. It just cuts. It just falls down straight, and that shows that this is an MA process and all that. Now you can also check with the PACF, and that's it. So now we're going to be importing real data for our analysis. This is where what I was just doing is just to let you see how you can generate random time series variables or time series data on your machine to really analyze and all that. What I'm going to be doing this time around is to import this data set, which is macro data. I'll try and see if I can put the link of this data set on the YouTube channel probably, but if I'm not able to put it there, please just find a different data set and follow. Now we have it over here. Now this macro data set, we need the read.excel to be able to get this thing out. Sometimes if you have tidyverse or what have you, it can come along with tidyverse, but if it is not there, means that you're going to highlight, or you're going to install that package separately. So I guess highlight all these packages and just run them once. I'm going to run them once, so they are all in. And now when they are all in, so I can then import my data. You can copy the path of the data. Now you should know how to copy a path to data file or the data set in your computer, so you can copy that one out and simply use that one to do your analysis. Alright, so I'm just going to run that, and I can view my data. I can view my data, so I can do this, and it's going to tell me now I have quarter, I have deficit, I have exchange rate, and I have inflation. This is data about this is data about Ghana, our deficit, our exchange rate and all that, and our inflation rate and all that. You can go to the Ghana Statistical Service, you can go online, and you can see, you'll be able to extract this data from the Ghana Statistical Service. So now first of all, one thing you normally try to do is to check the class of your data. You're going to be exploring with the time series data, so let's check whether it is a time series data, right? So this is a data frame. This is not a time series data. If it's time series, you see TS over here. Alright, so if you are going to be picking some values, or if you are going to be analyzing based on time series, then you have to be converting them to time series before you can analyze. Because if you are going to say plot with just this data, it's not going to work for you, because this is not going to be a time series data. You will see an object that you cannot really interpret, or you cannot really say something good about it. So now look at our data over here, macro data. If you want to get the year for these various columns or these various rows, you can extract it out. You can extract the years, the date, and everything out. So I'm going to do macro. This is the data that I have here. I gave this macro data a name to .macro, so I can just use the macro. That's the name I decided to give it to it. So you can give it any name of your choice. It's not compulsory that you should give it macro. You can give it any name of your choice. Okay. So now I'm going to say macro, and the dollar sign is just going to add another word column to my data. I'm just going to say macro, and I'm just going to put dollar sign quarter. So that is the data, the name that I want to add, the column that I want to add, the column name that I want to add. That is the quarter, and I'm going to say as.year QTR, and I'm going to extract the year from the quarter data set. I'm going to extract the year from this data set, from this column. I'm going to be able to extract the year from this, and from the year I can then extract the date from it. Okay, so over here I'm going to extract this from it. So if I just hit run, and now when you view a macro again, let's view it again, you can see that another column has been added. We now have what? Macro, the quarter here, which we did added. We now have quarter here. Now you can also add date to what you're coming to do here. So now you can see a macro dollar sign date. That's the column name I want to give it to it, and I do as.date. I want to get the dates, and I want to get the date from these. I want to get a date from this quarter, because I'll be able to extract the year from the bigger quarter. So I want to get the date from that quarter. So I'll just hit my run. And now when you view this again, you can see we now have date added. We now have date added over here. You have the date added over here, which is very, very good for you. You have the year, the month, and the day, and now that makes sense, right? So it is very, very impressive. From this, you are able to extract the year out, and be able to extract the date out, and that is really, really impressive. That is really, really impressive. Okay, so now over here, I want us to really explore the exchange rate. So I want to convert this exchange rate to a time series data. Right, so I want to give it a name EXC. That is exchange that I want to give it to. So I want to convert just the exchange rate column. So to convert that, I use macro and dollar sign to select the column that I want to convert. So now with that one, I hit run, and I have it over here. I have it over here converted to what? To time series. Now if I should check the class, if I should check the class of this EXC, if I should check the class, I'm going to be seeing a TS showing what is a time series data. Look at this. Look at it over here. It's a time series data. Look at it over here. And now we can. One thing we normally try to do is to get to know our distribution, right? If you have a data, you want to know the distribution. Is it normally distributed? And all that. That kind of helps you to be able to check outliers. But today we will not be doing box plot. I just want to take you guys through how to make a histogram plot with just the ordinary R. You can also do histogram with ggplot too. That is very, very good. It's going to give you a very impressive visual or a very impressive image. So now when you have this done, you can hit, and now look at it over here. You are able to generate a very nice histogram over here. You can see that this your data is really skewed, but that will not be our focus. Our focus is just how to explore it and just to know how it is. And now one second thing here is density plot. Density plot is more or less like histogram, but unlike histogram over here, you just use a line. It is like a line that is going to give you that distribution. Okay, so to get that density plot, I'm just going to do plot density, and inside I'm going to give the data that I want to plot that density, or I want to make it that plot. So I just hit run, and you'll be seeing this. You'll be seeing this over here, and now you can change the color. I'll show you how to change the color along the way. You can see this one. It's showing you the distribution with a line, and that is how you can explore your data. Now we can go ahead and then plot our exchange rate to see how the trend. What is the trend of our exchange rate and all that. And now you can see that and you can see this is really like this. It kind of, there is that kind of trend rising and falling. You can see that after this point, you can see that it's just rising very steep. So I think this should be the early moments and all that. This should be the early moments, because if you are going to look at how the data, if you're going to look at this trend and everything that happened, I think you should know that this is going to be somewhere 2020 something there, when the COVID came. Possibly that is where Mostly you can say something like that. Mm, because something of that sort. And one thing we can normally do is to sometimes try to plot histogram and density plot at the same time. You can plot all of them at the same time. So I can plot histogram, and to get density, normally with density plots, you can see over here the lines are in probabilities. So to be able to plot histogram and density plot at the same time, you have to set the probability equals to what, true, to be able to get that thing done, because the lines here are probabilities, and histogram will just give you random values, bigger values, not probabilities. So we set probability equals to true, then we run. So over here we are done with the histogram. It will come. Then we want to join our line. Now the histogram, I'm going to change the color. The color I'm just giving it color light blue, so you can give it any color of the choice. So I'll just put that. I'll hit run. It will come. You can see that I'm giving this color to something like that. So you have it over there too as well, and you're able to do that over here. So we can then do our. You can plot this again to get that. And normally we say data sets, data that is like this is non-stationary, because it doesn't hover around the mean, or it is, you can see over here, it's just going up, it doesn't hover around the mean. You can say this is not stationary. So to get that, normally we can plot our rolling mean. Rolling mean, that is just to plot the roll mean to see how it's going to be. So we can plot our rolling mean. So I'm going to do rolling mean, a name I want to give it to it, and I'm going to also add my standard deviation. I can roll standard deviation too, and I'm just going to plot them together with what I've done over here. So let me use this plot, because the auto plot is giving me problems. So let me use this plot, and let's just use lines this, and you can see that I'm setting the color equals to blue, and you can see that our standard deviation is somewhere around 0. And let's try our mean, and you can see that our mean, the red color, look at it over here, it's not hovering around 0. This is even a proof that this is not stationary, because look at the mean over here. Look at the mean over here. Alright, so now what I wanted to just touch last is stationarity test. We learn how to do stationarity test, and we learn what the augmented Dickey-Fuller test, which is this one, and we learn the KPSS test. So I'm just going to show you. To do that, you just need to do ADF of the test, and inside you put in your data that you want to test. Okay, so over here you do it like that, and you can see over here it's going to give you the Dickey-Fuller. It's going to give you the p-value and then the lag order. You can set the lag order too if you want. It's going to give you the lag order in order. So they're saying the p-value is greater than printed. That means that it is really greater than the printed value here. So you can also add the KPSS test, and this is what it's going to give you. Thank you guys very much. If you have a question, please put it there, and please like and subscribe to this YouTube channel. This is Ken Nash Data Science Hub. Thank you guys very much.